Imagine that you are running a poll. And in this poll, you ask your consumers from one scale from 1 to 5, where 1 is not concerned and 5 is very concerned about environmental consciousness. So you are trying to evaluate within your customer base which customers are very concerned with environmental issues. And then you have a scale which goes from 1, 2, 3, 4, and 5. And this is the environmental concern rating. And on this axis, you're going to have the number of environmental purchases this population of customers are doing. Now, what you would expect is that obviously people who ranked really low in terms of environmental concern, they don't actually do many purchases. And people who rank really high, they will do much more environmental purchases. And then people in the middle will also do a relatively rational amount of environmental purchases. So you would expect a line like this, right? Where you have, this is the expected line. Right? So that the expectation that we have, the intuition that we have, is that the growth is going to be linear. However, this has actually been done in practice and reality, and what we observe is something like this. What is really interesting about this particular case is that the vast majority of purchases are executed by these customers, those who are extremely concerned about environmental issues. Those who are moderately concerned about this are much lower. They do much less purchases. See, so you see the gap here than expected. And this is one of the properties of these nonlinear systems. Essentially, what you're seeing here is that our expectations tend to be linear. However, in practice, we observe these curves, and the real behavior departs from linearity. And then you see a vast majority of people who have a high environmental concern rating executing the purchases. This reminds you a little bit part of the principle, right? Which is that 80% of the purchases will be done only by perhaps 20% of customers, right? So this is one of these cases where you would have this kind of Pareto distribution. Let's look at a slightly different example. This example goes about understanding the relationship between price, so we have price, volume, and margins. And it also goes in the direction that it breaks our intuition regarding the relationship between these three variables if it's not linear. Imagine that you have a product that costs you 15 cents to produce. So this is the cost to produce. And you're selling this product. This is the price. And this is the different offers. So usually, on the normal offer, you would offer this product for 50 cents. So you're having a profit here of 35 cents. Then you make a promotion where you have a 20% off, 20% discount, and then you offer the product at 40 cents. So here you have a 20% off. And you have a second promotion where you have a 40% discount. So this is promotion number 2, this is promotion number 1. And here you sell the product at 30 cents. In this particular case, you have now a margin of 15 cents. So how many sales we get? Well, we got obviously some sales. So when the price is normal, we get 1,000 units being sold. And then at 40 cents with a 20% discount, we got 1,200 units. And this is an uplift of 20%. And here we got, 1,800 units for an 80% uplift. And you would think that this is much better than this case. This promotion, right? You might think it's the best promotion. But in fact, this is the better promotion, the one in the middle. And we can run the numbers and see that effectively this is the case, because at 15 cents, which is what the product costs, we are going to have a profit here of 350 in the normal case. Here we're going to run at 300, but here we're going to run at 270. So even if we increase sales in terms of volume by an 80%, we are making way less than when we only managed to increase sales by 20%. And this is remarkable. And the reason why this is happening is because the relationship for a constant amount of money that you want to get from the sales of these products is calculated in this way. So you have the price of the units, or the price per unit, right? It's 50 cents, multiplied by the volume of units that you sold. And for this reason, keeping K constant, you will end up having this inverse relationship. So you end up having this curve where here you have the price per unit, and here you have the amount of units necessary to sell for a particular amount of money that you want to do, K. And this curve is going to look like this. It's a nonlinear relationship, as you can see here. So this is what causes this strange behavior in the percentages.